Thank you for this invitation to talk about the exciting future of surgical robotics. You know, in this field, I feel like we're living the future every single day. There's something exciting, something new, something progressive, something contributive to society happening all the time. And it's essentially been an exciting future for over 20 years. So I want to start this presentation with a story from the past. In 1770, Wolfgang von Kempelen began touring Europe with a new device that he and a friend had invented, and he called it simply the Turk. We have come to know it as the Mechanical Turk, and it was a mechanical device, as you see in this drawing here, which purported to be able to play chess as well as any human. And Kempelen would arrive in a city and set up at a city center or an opera house or in the mansions of the wealthy. And he would put on a show where he would invite the audience to come up and play chess against his Mechanical Turk. But in the presentation leading up to the invitation, he would open all the drawers and show them the very complicated wheels and gears and pulleys that made this possible, and explain to the audience that it was so advanced that they couldn't possibly understand how it works, but that he would demonstrate if a member of the audience would come up and volunteer to play against the Turk. And the member of the audience would come up and they would play a game of chess. And when it was the Turk's turn, the Turk's arm would move and that staff that it was holding would push a chess piece from one square to the next. Now, 250 years later, you and I can hear that story and we absolutely know there's got to be a trick to it. There was no way that a machine in 1770 could play chess at any level at all. And of course, the trick was there was a small assistant that was inside the machine, and that assistant was equipped with handles and levers that allowed him to move the Mechanical Turk's arm and push the chess piece around. And he could see the chessboard through mirrors and windows, so he knew where the pieces were. Well, that's the predecessor of modern robotic surgery. We essentially have a man in the machine, and the machine does what the man tells it to do. That's the case for almost all of the robots that are available today. Colorful story. We've been on a very rapid journey from 1985, when the Puma robot was taken off the assembly line floor in a factory and taught to hold a probe needle that could be inserted into the brain, through the introduction of the ESOP robotic camera holder in 1994 and the Zeus robotic surgery system in 1998, through to the first Da Vinci system around 2000. And then through very many variations and improvements on the Da Vinci since then. These certainly aren't the only four, but they represent a very rapid change and rapid advancement in robotic surgery in a very short period of time. And when you look at the operating rooms today, you find that there are certainly more than one or two robots. In fact, there are robots being used to assist surgeons in almost every area of surgery. We can find systems that work in the abdomen and in the brain, but there are also systems that assist with eye surgery, ENT surgery, dental implants, procedures on the thyroid, procedures on the surface of the skin, heart and lung procedures, the drawing of blood, entering through the urethra, cardiac catheterization, hip and knee procedures, which you're very familiar with, transanal procedures, and several in spinal surgery, and even one that assists with hair transplantation. So there are devices being created to help all over the operating room and all over clinics when the procedures are done outside of traditional hospital environments. But most people don't realize how many different companies are participating in this gold rush for robotic surgery. In the 2 years that I have been following this and compiling lists, I have been able to find 88 different companies that are trying to create a robot that will improve surgical procedures and contribute to the health of the overall nation or country or world. These 88 companies include the major medical device companies like Medtronics and J&J, and they include well-known robotic specialty companies like Intuitive and Globus and uh, Mako, things like that. It includes all of those. And it also includes lots of new startups that are very well funded. VCs are putting money into dozens of companies to the tunes of tens of millions of dollars to get them up and running and try to contribute and participate in this surgical and economic transformation. These 88 companies represent more than 88 robots. Many of the companies are producing more than one robot, and so the number of robots is north of 95 itself. So this has happened very quickly. I mean, if you say there's one in 1985, and they're a small number, less than half a dozen in 2000, and then 20 years later, we're up to 80 to 90 different robots that I'm aware of and have been able to compile and put on a list. Understanding 88 different robots, 90 different robots can be challenging, and explaining it to somebody who's new to the field and trying to get introduced to it is completely daunting. So to assist with that, I have identified 4 different categories of robots that roughly include all of those systems on the previous slide. The first category I named the Surgeon Waldo. And the term Waldo is not derogatory. It's actually a reference back to a 1950 science fiction story by Robert Heinlein, in which he popularized the idea of a human-controlled robot. And those devices in Heinlein's story and in the operating room today essentially transfer, scale, and stabilize the surgeon's movement. They're linked to the surgeon, and those surgeon Waldos are typically systems like the Da Vinci or the Flex or the Senhance or several others that follow that same model. The next category adds something to that, makes the robot a little more active, and I've called that the assistive guide. These assistive guides are loaded with a preoperative plan, and they force the surgeon to remain compliant with that plan. They're more active in holding the surgeon's hand and in restricting the surgeon's movement, so that if the plan is exact and precise and correct, then the execution will be just as exact and precise as the plan was. And you're familiar with those in the Mazor X, the Excelsius, Mako, and some others that fall into that category. And then taking robotic assistance even further, you have programmable automata. These are devices where the plan is programmed into the robot, and the robot knows how to conduct the entire plan on its own. And so the surgeon stands back after loading the plan and starting the robot, and the robot does all of the work itself without the surgeon being involved in the active treatment of the patient. And you see that in systems like the CyberKnife, where it's applying energy to the human body in complex patterns that a human just couldn't do. And in the RTAS hair transplantation robot, which plucks follicles of hair out of the human head. And then finally, you have motorized laparoscopy. These are typical hand tools of endoscopy or laparoscopy that have been enhanced with motors and sensors to give them more capabilities and to allow them to provide assistance and capability to the surgeon that typically have existed in the Surgeon Waldo category. So like endoscopic wrist manipulation is very popular in some of those devices. These 4 categories are very helpful in narrowing down 88 different stories to just 4 to get people started down this path. And understanding any system in more detail requires more explanation, but at least you can get your mind around it with 4 categories instead of 88 categories. Where do these robots come from? As many people would expect, 34 of the companies are headquartered in the United States. 8 of them are headquartered in China. 7 each in France and Germany, 6 each in Israel and the UK, 4 in the Netherlands, such a small country, and then proceeding downwards to 1 each in several countries. So as you would expect, a lot of this innovation is happening in the United States, but the United States certainly doesn't stand alone. There are a half a dozen countries that are making very significant contributions. And China's position is most notable. When I started compiling the previous slide and keeping track of which countries those were coming from, China had exactly 1 robot on the list. And partially that was because some of the robots were still undercover and weren't being promoted, and information wasn't available internationally. But it's also true that in the 2 years that I've been compiling this information, China has climbed up this stack of countries, and is approaching the United States and will continue to do so. I think their trajectory in robotic surgery will mirror their trajectory of progress that is happening in other technological areas. And you can expect them to be bumping up against the United States in the next several years. Now, as these robots have entered the hospitals, they have had a number of very positive impacts. Some of the forces that are very well known to everyone is the way that it improves the fidelity of the surgeon's fine muscle movement inside the body. It improves accuracy by reducing the variation of a procedure. It can improve efficiency and the throughput of both the surgeon and the hospital. It can improve surgeon and staff health by doing things like taking the surgeon out of the energy field or not forcing them into very ergonomically damaging position for hours at a time. It's less invasive to the patient, and so impacts them much less than other procedures have in the past. And then another positive force is economic for the country that is inventing these devices. In some cases, the nations are supporting the development of robots in country because they recognize the positive impact that will have both to their reputation and to their national economy. And so they'd much rather be on the exporting side of these devices rather than the importing side of these devices. Along with those positive forces, there have been a few negative forces. And the popular press loves to point to the device costs and the instrument costs, which are typically higher than the older methods of doing it. But that's true of every single industry. When you introduce any kind of new technology, it's always more expensive than what it's replacing until it gets its feet under it, and mass production can bring those prices down. Advancement of the technology even further brings it down, and competition brings those prices down. So that's not unique to healthcare. That's universal as progress happens in every field. Another negative force is the facility space that's required. Space in the operating room is always competitive. It's always at a premium. And space in the hospital to store the equipment and the robots is always under competition. So somebody's always asking for more space than really exists. There is a requirement for staff training beyond just the surgeon. The other staff in the hospital and those that are involved in instrument processing have to be trained to work with the robot and to clean the instruments and bring them back in a sterile fashion. And then finally, the hospital marketing team is challenged. When a hospital had exactly 1 robot to promote to their local patient base, you could create a story that was very clear and that said robots means one thing. But now that there's a half a dozen or a dozen robots in a operating room or in a hospital, the marketing department is challenged to explain those robots at a level that the general public can understand and explain the benefits of it in a way that is unique for every single robot, and doesn't confuse the patients and confuse them about the advantages of robot A with the advantages of robot B, and they're actually being considered for a procedure with robot C, and they have all those advantages blended together in their head. I think there's another area of robotics that's brand new and just being pursued by a very few players, and that's the soft side of robotics. Robots have typically been considered a hardware device that has very little software inside, or at least little software that the external user can really appreciate and participate in. But if you imagine that a robot is driven by an operating system in the same way that your cell phone is driven by an operating system, and you use the Android operating system model, you could think of a future when a dozen different robots can be invented physically, and all 12 of those are being driven by the exact same operating system. So there's a general robotic operating system that is appropriate for a dozen different robots, and that operating system doesn't have to be invented and validated and approved every time a new device comes on the market. That operating system, if it follows the cell phone model, would be connected to the cloud so that the data from every procedure isn't lost or fragmented, which is almost the equivalent of being lost, but can be brought together into registries that are not just contributed by humans and other IT systems, but registries that are contributed to by the robots themselves. And that information can be studied and learned on by machine learning algorithms and by scientists who can find important trends and create best practices based on millions of procedures and thousands of experienced surgeons contributing to it. That's a world that doesn't exist in a smooth way today, but does exist on your cell phone and could certainly make the same kind of contributions in robotic surgery that are being made in other areas. That standard operating system might also have an app store sitting on top of it. The app store means that every instance of a robot doesn't have to carry every single program that was ever written for that robot. The surgeon and the hospital can download the apps that are specific to what they're doing with that robot. And so one app might be specific to a unique instrument or a unique endoscope or a unique kind of overlay or voice recognition or telemedicine capabilities to bring advice directly into the robot. When you open up that environment to the rest of the world and allow a select number of responsible developers to imagine what app would be useful in a robot, I think you'll have the same kind of explosion of imagination and capability that you had when Apple first invented the App Store and allowed developers to contribute to their platform. At first, we couldn't imagine any new apps that would fit on a cell phone. And now we can imagine millions of different applications that people might benefit from. And I think the surgical robotics environment would have that same explosion in innovation if an app store were available beyond just the manufacture of the hardware. Those kinds of apps are probably, and that ecosystem, the whole ecosystem, is probably not best suited to the traditional device manufacturers. It's companies like Google, Microsoft, Apple, and even Facebook that are really good at creating that kind of ecosystem that stretches into the cloud and out to the edge devices. And so I think you could see them playing an active part at least in creating the infrastructure, if not actually in creating some of the capabilities that you see on the robot. And if you're less American-centric, you would see that same thing happen with Tencent and Alibaba and Baidu in other countries. So I think there could be a very big change there. And finally, I wanted to wrap up with a few capabilities that are happening or that seem like they should happen. We've mentioned machine learning and AI already and the role that those could play in improving surgical care and understanding what's happening in surgery today. But miniaturization is also a factor. Many of the capabilities that you see in the Da Vinci robot or the Mako robot that are cabinet-sized devices, you're starting to see that technology miniaturized so that it can be used in a robot that just operates on the eyeball or just operates on the inner ear or other forms of microsurgery. And so miniaturization of robots down to things that fit on a desktop because they're doing a much smaller job is already happening, and that's certainly going to grow and happen more. And how would you like to be free of that soda straw view that you have inside the body, where you're constantly stirring your soda straw camera around to look at what you need to see in the body? With optics and small cameras, it's possible to image the entire inner abdominal area at the same time, and to take all of that imagery and stitch it together into a 3D view that a surgeon can see at all times. And so instead of having your hands steer the camera left, right, in, out, up, down, so that you can see what you need to see underneath that soda straw, that you could see it in 3D inside of a virtual display on your head, and you use your head to look around and see the inside of the body that's being imaged at all times. That certainly should be available with technologies that are out there today. And then finally, could we transfer much more of the dexterity and capability of the human hand to the end of the instrument, so that instead of all instruments ending in a two-fingered grasper or a simple pair of scissors, they would have much more dexterity and capability, and that what the surgeon can do with their hands translates to the end of that instrument. And if you think about the programmable automata that I talked about earlier, the capability of the human hand isn't the limitation. When the robot can execute the operation itself, it's no longer limited to what it can do in response to human hand movement. And so these instruments could be far more complex than just a five-fingered instrument. All of those are capabilities that make the future and the present very exciting in this field. And so I'm happy to have been able to share this with you all, and I appreciate your invitation to be with you. Thank you very much.